know if any of you are connected with this project. We are building some terminals that will be sent to Australia. Liam Connor is the astronomer here that's doing this, and I wish I knew the name of his contact in Australia, but let me tell you what the terminals are. They are just horns with very low noise receivers operating in the band of about 1300 to 1500 megahertz around hydrogen line. And they look at a wide view of sky that is, as many of you may know, fast radio bursts come from random directions in the sky, and they usually don't repeat. There's a zip that comes through the receiver, a swept frequency, sweeping down in frequency over, say, 500 milliseconds or so. And they come from neutron stars. And there's many each day, but most of them are missed because you rarely have a telescope that's pointed in this random direction that they're coming from. They're extragalactic. You see, they're coming from other galaxies all over the place. And the receiver is very simple. That is, well, the analog portion of the receiver is simple. These are low noise amplifiers viewed with a horn with a beam width of maybe a radian or so. So you have more of a chance of catching one coming from a random direction. The collecting area is pretty small. It's just the L-band horn. A graduate student at Caltech about 3 years ago built 3 of these horn receivers, spaced one in Utah and 2 in California. They're spaced to reject common RFI. They're far enough apart, so when a burst comes in, it's usually needs to be astronomical. And sure enough, he detected one about 3 years ago, and now other people have jumped in and built. We're building 9 of these, and I think 3 of them are to be shipped to Australia. Wanted to get some Southern Hemisphere coverage. And I wish I knew more about it. If any of you are particularly interested in this, you could send me something through the web or the call it the.
They can. You guys can either send it to me or put it on listserv and ask Sander, and then I'll make sure he gets it.
If you wanted to find out more about this, maybe participate. But it's also a opportunity that is out with a small antenna. Now, when I say the analog part is simple, but the processing is not so simple. You need a multi-band receiver, hopefully covering 100 megahertz or so with channels of the order of 1 megahertz or less. And you have to process that filter bank to see this swept pulse. So you you have to have a search that looks through the spectra that are received and looking for the swept frequency signal. But it's not that hard to do, and maybe some of you are interested in trying to capture fast radio bursts. So there's a lot of articles now about fast radio bursts. It's a hot topic in radio astronomy. What causes these? They're believed to be neutron stars, but why do they just pop once? And it's pulsars are also neutron stars, but they're rotating. And when the bright spot on the neutron star faces the Earth, we get a pulse. But this is quite different. This gives the pulse. And little history, I think there's been 1,000 of these seen, mostly by CHIME, an array in Canada. Caltech has seen maybe 10, 20 of them. But there's a lot of theory going on, what causes these. And there's a few of them which repeat. Not repeat like a pulsar, every few seconds or milliseconds, but repeat over maybe an hour or two or the next day. So some people, they find the location of where a FRB had occurred and just stare at that location for days. And that way, some of the repeaters have been found. And that's valuable. Then you can look with other wavelengths. Yeah, why don't you check who's at the door? Yeah, somebody just rang the door here. Anyway, that's just a little announcement that I made about some connections with.
Sander,
Yeah, go ahead.
is there any frequency content to that, or is it just broadband?
It's
Spectral content.
yes, it's spectral content, but it is also time domain. If you look at one frequency, you see a pulse at that frequency, and it's only a millisecond long. But if you look at a lower frequency, you'll see that same pulse, just delayed by, say 10 milliseconds.
It's dispersion, just like the
Yes.
pulsar,
Yeah.
right? Yeah.
Excuse me, I gotta answer something at a
Thanks,
door.
Sander.
Yeah. All right. Thank you.
All right, yeah, if anybody's interested, yeah, you can
Contact me. Yeah.
yeah, contact me and I'll forward it to Sander and see if we get this.
Good.
Yeah,
Thanks.
Thanks.
Okay.
Yeah, I think what Sander was talking about was the DM.
Yeah.
So the signal, lower frequency signals, lower or higher frequency signals move faster through the medium. So based on that, you can actually figure out the distance and tell it's an extragalactic pulsar or galactic pulsar just by how big the DM value is. Yeah, but mostly it's broadband. You can usually pick these guys up at almost any frequency. We pick up pulsars between 400 megahertz and 1420 megahertz, and anywhere in between. Usually the lower frequencies are actually brighter. Okay. Let's see, Alex, what do you got going on?
Just before we go on, Rich.
Oh, I'm sorry, Paul. Go ahead.
To know, if they're shipping them to Australia, do they have sites in mind already for those receivers? So perhaps you don't know, but perhaps we can find out from Sander.
Well, we'll figure that out.
Yeah.
It sounds like a cool opportunity if, or maybe they can ship a couple more make a couple more up if you got some interested parties down there that can do it.
Yeah, I'm sure. Well, it's two ways. If they've got sites in mind already, if we can then liaise with whoever's hosting them.
Right.
But if they're looking for sites, that's a different question. And then we put out request expression of interest to host one of these. Would be good.
Well, I think you'll find if you throw Sanders' name and vein around, he's can open a lot of doors for you. Everybody knows him.
Yep.
Okay. All right. Well, Paul, do you got any? I didn't want to jump in, but do you got anything else? Any more?
Well, I saw Joe. Joe, have you got anything from your end?
No, not excuse me. Nothing except catastrophe. I had a major failure of the PC, and the drive C died on me. Whilst trying to set up stuff for TED, but drive C has died, and I'm just now in the middle of rebuilding the thing. So it's a little solid state drive just left this planet, and that's the situation I'm in at the moment. Still trying to rebuild things back to where they were sort of a week ago. So beyond that, nothing. And apologies for not turning on the camera. I was having breakfast, so I was listening to you all. So,
And Joe, were you at the meeting on Monday evening? Because I wasn't able to get to that.
yes, I was. I had to leave early, but yes, I was for the majority of it.
Was there any progress on the dish reported?
Yes, I'm not sure how far you're aware of, but the block which the worm screw, the worm has been handed across, and I think 2 of them are being manufactured, and the hope is that we're back on air and sort of for springtime. So that's only about 2 months away, I guess. So hopefully we'll be back on air at that point. I wanted to, but nothing was said about it at the meeting. Again, like I said, I had to leave early. We have a horn at the site, and I was hoping to be able to collect some data using Ted's system for that, and I'm still working on that here at home. But beyond that, no, nothing. The computer has really just a dead halt to me for the past couple of weeks.
Okay. All right. Thanks, Joe. And the one thing I've got here, Rich, is Steve's report. Do you want me to quickly just whiz through that? I think you're going to put it in the journal. Rich, is that right?
Yeah, it's already ready to go. So you want to go and go over it real quick, or?
I'll just do a quick whiz through, which should have appeared. Is that right?
Looks good.
So this, just refreshing memories. This is Steve Bentley trying with the Astronomical Society of Victoria, trying to get some thermal stabilization into the system, and it's a good opportunity while our dish is not operational. As Joe says there, the worm drive is on its way, and probably 6 weeks or so, and then we're back on the air. So Steve's been doing this work to try and stabilize. Now I can't give you the detail that Steve would, but this will end up in the Sonic Journal, so you can have a read through. You can see it's it's experimental at this stage, but I think some of this we've seen before. So this is his like breadboarded version of trying to get all the power in the right place, but also get the temperature stabilization going properly. And now we're getting the proper boxed version in here, and using these Gore vents to try and maintain the humidity. or avoid humidity, I suppose. And then we've got temperature sensors in here so that we can monitor what's going on. As I say, Steve will give you much more detail.
Is the box heated? Is that you're heating it above outside ambient?
We're going the other way. We're trying to keep it below outside ambient because we get temperatures up 40 degrees and more in the location because it's out north of Melbourne.
How are you cooling it then? Is it just fans or
where are they?
How do you get cooling?
Yeah, I'm just looking for. It says it in here. It's a pity Steve's not here. He's got all this at his fingertips. But the what do they call them?
I just jumped.
Coolers, solid state coolers.
Using
Yeah, it's a solid state Peltier.
Yes,
cells.
right. Okay, sure.
Yeah, Peltier cells.
Yes.
And he's had reasonable success in maintaining a fairly stable temperature. But of course, we haven't had a chance to test this at summer temperatures. It being winter here at the moment, we're getting some very cold nights, frost even up where they are. But we're not able to test it at the 35 and 40 degree daytime temperatures that we experience up where this dish is located. But he's had quite a lot of success with those Peltier cells.
Where is the hot side of the Peltier cell connected? In other words, it's pumping heat from inside the box.
Where is it going? Very good question. Yeah. I wish Steve was here to answer this.
Can I jump in at that point?
Of course, Joe. Yeah, go ahead.
Yeah, the very first photograph you showed, right at the top of the thing, is where it's being vented to the outside, Sander. Is that thing there? That is a the Peltier device is underneath that black rectangular thing.
Yes.
And that little thing to the side, the angled piece, is a 3D printed enabler to put a hose on, and it's being exhausted to the outside. On the right hand side, it looks like a V on it, is a fan which is actually driving the air to the outside. So it's being exhausted.
So the outside air is still cool enough to cool the hot side of the Peltier.
Well, that's I think that's probably the unknown, whether or not because it's only able to maintain a differential, whether or not it will maintain that differential right up to the very high temperatures. That's unknown at the moment.
Okay, what I just mentioned here is some articles that we've seen about paints that are very good infrared emitters and good reflectors at visible wavelengths. What these paints can do is at night, when there's no solar heating and the infrared is cold, they will cool down a box like this 10, 20 degrees below ambient. It can get very cold. And this is due to this special paint. During the day, the box can be below ambient, even with it in the sun, just 1 or 2 degrees below ambient.
Yeah, we are aware of that paint. I'm not open this side, but I know just from listening to Steve talk, we are aware of that paint. It's actually being tried on some of the field area where they've got cameras for astro stuff, for astrophotography stuff. They have a section painted, and it's actually being tried at this point in time to just to do what you're talking about. It'll keep the ambient temperature of the ground down below what this everywhere else is. So yeah, we are aware of it, but I don't know if anybody's actually tried anything in respect of the dish. But it is being tried in other areas. Yeah, it seems to be quite. I think it's black magic involved in the paint.
Well, we're building an array in Nevada where it gets very hot. We're going to have a lot of boxes. And I'd like to see, is this a report, or where could I see some of these figures?
Yeah, it's a report. I'll send you the copy, but it's going to show up in our journal in about August 20th.
That's soon enough. All right.
I'll just send you the copy I've got.
All right. Thank you.
I'm just looking for any data. There is some setting of thermostats there. And yeah, while this is showing you the what we're up against, which is the temperature range at the location in Heathcote across the year. And I mean, these are averages, so you're going to get above those. So this is showing what 30 degrees here, but it certainly goes higher than that. So that's the challenge that Steve is up against. I'm not quite sure. Joe might help. What the most recent outcome of Steve's measure was.
Well, you're basically looking at that. What that is, I think, is a plot of the gain of the system with variations in temperature from what he's been able to do at home. Okay. He's hitting the thing and looking to see if the gain does drop off fairly linearly. That's the front end. There's another bit for the back end where we had problems with stability, which looks a bit better than that. Yeah, it's still an ongoing process.
Yeah. Well, that shows very clearly what the issue is. If we're against temperature here, we're only up to 20 degrees here, and we've already got a delta of 0.7, which is significant. Just go further down, see what else. That's the Peltier. Well, again, breadboarding to see whether it's going to work. But I think I might leave the details to Steve when he's here, perhaps next time, Rich.
Sounds good to me.
So I'm not, yeah, well, it's showing stability, but whether it's still stable at the right temperature, that's the question. Yeah. So I think I might stop that share because I haven't got enough detail and background to expand on what it's telling us. But if that goes in the journal, Rich, then that people can read through, and then we can perhaps have further discussion after that.
Sounds good.
Thank you.
The plan.
I have to go in a little while. I just wondering, my area of concentration is LNAs, low noise amplifiers. I've worked on them for 50 years for radio astronomy. If any of you have some questions about LNAs that I might quickly answer or try to answer quickly, please come on. Are you using commercial LNAs? Are you making your own? What LNAs are you using?
Yeah, these are commercial ones. See if I can find
MIDI circuits. They make some good ones.
I have a question for you.
All right.
Okay, I've been through the NRAO center at Socorro three times. The cooled LNAs that they have there have an LED in them that is running inside. What on hell is that LED for? They wouldn't tell me anything.
Well,
Why shine an LNA on the junction?
yes. Years ago, we found some LNAs that degraded unless they had some light stimulation.
Really?
The purpose of the LED was just that. There was a drift of current, I think it was. This was 10, 20 years ago that we saw this, and we started putting LEDs over the transistor. But I haven't heard of that problem for a long time. I think that was some impurities in the transistor, and just to be sure, it was very simple to put an LED on top of it.
That's interesting. Thank you. I think maybe they didn't say because nobody really knew.
Yes, right.
That's great.
Sander, this is Richard. What's kind of the state of the art these days in low noise figures and low noise temperatures?
Yes. 7 Kelvin with an LNA at 25 C. 7 Kelvin noise averaged between 1300 and 1500 megahertz. We've now built about 200 of those. It uses a very special transistor from Duramix company in Switzerland. And it's a combination of this extremely good indium phosphide transistor, which cost about $100, incidentally. I mean, it's expensive, but worth it. But it's a combination of the good transistor and a very low loss input circuit, input matching circuit, which it can't be microstrip. A tenth of a dB loss is 7 Kelvin, and the whole amplifier noise is 7 Kelvin. So the input circuit loss is in the hundreds of a dB. And it's a suspended substrate. It's a large amplifier because this input circuit needs a long line to have low, and it has low loss. There's an article, MPT article. If you look up my name, Weinreb, our article was published a couple of years ago about this 1300 to 1500 megahertz amplifier. What we're working on now is a 700 megahertz to 2 gigahertz amplifier, which has about 11 Kelvin average noise over that band. I should say too, these amplifiers are very gain stable. From let's see, minus 40 to plus 40, the gain only changes a few tenths of a dB. The noise is quite sensitive to temperature, going down with lower ambient temperature. And that could be a stability problem if you're trying to just use the amplifier without any switching. But that's what's going on in low noise amplifiers now. I think it's how high in frequency can we go without cooling. Right now, we're up to 2 gigahertz.
How do you measure those low noise temperatures?
Very difficult. I built at NRAO in 1985 some liquid nitrogen noise standards. It is Maury Microwave makes one now they sell. But I borrowed one of those back from NRAO. It was in Greenbank. If you go to Greenbank for this Eastern meeting, you might see some of these jugs. A little tank that has an SMA or a type N connector on it. And it goes to a termination that's in liquid nitrogen. And the loss between the connector and the termination has to be measured and corrected for. But the quick answer is that we use liquid nitrogen standards
I see.
to measure the noise.
Thank you.
Well, I think,
And
go ahead.
I shared that picture for Sander. He was asking what LNA was there. That's the one that I can see in
Okay.
Steve's.
I see the 0.290 dB noise figure. Well, that was good 5 or 10 years ago for room temperature amplifier. Let's see, that's 0.3 dB is about 20 Kelvin noise. You can do better than that now,
Right.
but with an expensive transistor and a bigger input circuit.
That's from WD5AGO, Tom Henderson. That's what I use, that LNA.
Is he in England? And you get it from, where is he?
In Texas, I think.
Okay, all right. No, I don't know
WD
that one.
Whiskey Delta 5 Alpha Golf Oscar.
Okay, all right.
Yeah, just a comment. Wolfgang, I guess, got 2 of these LNAs that Sander provided him. And I think he credits it with his FRB research because it basically made his 25-meter dish equivalent to a lot of the professional dishes that are using cryogenics to cool their LNAs. And since he doesn't have cryogenics at the feed point, he's almost as good as they are, or he might be better, without any cryogenics. So I think that's your benefit, is you get, your first LNA is really important to drive your whole noise figure.
Sure. Well, the big benefit in radio astronomy is that we could have large arrays. We are now planning a 2,000 element array of 5-meter telescopes to be built in Nevada. And the cost would be out of sight if it needed cryogenics on each of the 2,000 dishes. So the room temperature LNAs, even with $100 LNA, I mean, we're talking about maybe $200 for the whole LNA, it makes it feasible to have large numbers of antennas, and we're doing that.
Will they be available that we can get them? Will there be some lead?
Well, I used to sell LNAs at Caltech, but Caltech doesn't want to do that anymore. We want to publish the data, and people buy the components and make them themselves. Whether somebody will start making them and selling them, there's some wire bond connections in the LNA. It's not so easy.
Right.
The chip that's $100 is a chip. It's not a packaged
I see.
just There's a fellow named Hamdi Manny in Arizona who's building them for radio astronomy. Whether he wants to start building them and selling them at a low price, I don't know. But it's something to watch out for.
I can comment a little bit on this. I've asked Sanders several times about getting these things too, and I haven't contacted Hamdi yet, but I've intended to do that. But I did contact the people that are making the die, and I have a background in semiconductor packaging in the past when I was working too, so I know a lot about that. It's not a trivial thing to package these die that he's talking about. In addition to that, you typically need to plan on some yield loss. So if you're going out and buying these die, the kind of volume that I approached them and said, can I buy die from you? And they came back and gave me a quote, but it's a little more than the price Sanders getting, but he's getting a better price because he's buying more of them. Now, Hamdi may pass along some of that benefit because he's sort of the in-between man in this picture, I believe. He's buying them for Sander and building the things, but he's in business to make money too, and we can't knock him for that. He's a very talented.
We're buying them and furnishing the transistors to Hamdi, and he does the assembly and testing.
Okay. Well, he's been written up in IEEE. I'm a member of IEEE in the microwave group too, and a couple other places, and he's got an interesting background himself. And anyway, he's
talking about Hamdi now, or the fellow at Dynamic?
Hamdi does. Hamdi.
Hamdi.
So it's on my agenda to contact him, but I have several shortcomings about it though, and that is these are very sensitive devices too, and you have to be very careful with them. And it's not unusual for you to blow your LNA if you're not careful and paying attention. You can't be sloppy about your work. And if you put some kind of a relay or something in the front end to short it out, like if you're going to have bad electrical storms coming through, that's going to add noise to the system. It's not going to be good for you. So anyway, I've visited with Wolfgang about this a little bit, and I know, he's sweating too because he's only got 2 of them. If something happens to one of those, he'll be in bad shape. And Sanders is going to have a crew of guys that run around and change these out occasionally too in the 2000 telescopes.
Well,
they need space. But the state of the art is more like the one y'all were showing in terms of easily available stuff for people like us right now. I build my own here, and you can get several devices from mini circuits and do some of that type of work. There's a guy named Sam Jewell in the UK that has built preamps also in the past for a lot of people, and he does a decent job. I think he's still doing it, but winding down a little bit. But he has a lot of good techniques that he's willing to share with you on how to reduce your LNA, and the surrounding circuitry on the input and the output is important and can make
absolutely. Well, let me just comment a little bit about the reliability. Of course, you have to watch out for static in assembling the amplifier, but that's pretty common. The bias circuitry has regulators on it, and all kinds of filtering. The one change that we made a couple of years ago that we didn't have an input coupling capacitor. We went directly into the transistor gate through this input matching network, which didn't have any series capacitors in it. And we were blowing LNAs, just connecting them backwards, putting 5 volts on the input. That blew the transistor. So there's now actually a coupling capacitor. And, we have to add that capacitor without adding 1/100th of a dB loss. And we have a capacitor that does that. It's a got the name of the company. It advertises very low loss capacitors, and it's something like 100 picofarad it's a large capacitor for the frequency. But with that, we now have about 200 out in the field in Northern California. Very rare that there's any failure of those, but have to be careful.
Yeah, you have an advantage in that you have a protected site too, and you don't have other people transmitting close by with some other kind of a radio or something
Sure.
that might overload
Right.
the front end. So
Yes.
you just gotta
Right.
you gotta pay attention to what you're doing if you're going to spend a few $100s on a LNA.
Yes.
But it will also lower your signal, your noise level very much, and maybe let you hear something you wouldn't hear otherwise.
You know, the argument is if we had, say, a 20 Kelvin LNA instead of a 10 Kelvin LNA, we would need 4,000 antennas instead of 2,000 to get the same sensitivity. So it pays off to pay the $200 for the LNA.
Hey, Sander, for us amateurs who probably just have the capability of buying an off-the-shelf LNA, is there some modification that would allow us to improve that? That a simple modification, like first level, that would help us get the noise figure down on a commercial
But you're still
LNA?
talking about buying an LNA. I mean,
Right.
It has a gallium arsenide transistor in it, probably, and just the microstrip input circuit is contributing 1/10 of a dB or more. So I don't see any modification of a commercial LNA to reduce the noise from 20 or 30 Kelvin. It used to be you could get 30 Kelvin LNAs. Maybe now you can buy a 20 Kelvin LNA. But reducing it further, I think you got to go to different construction techniques. So it's not a matter of modification.
Rich, there was a thread on the Google group, Sarah group, and about building LNAs, and so I posted and a few other people posted links to kits. I would never attempt it. I mean, I don't have the test equipment to do it, and it's extraordinarily tedious to do something like that. But there is information out there, and there are links, and you can look down and you can see the construction guide to building your own LNA.
There's not very many
But
parts
it's a
in one.
packaged transistor.
Yeah.
When it's packaged transistor just mounted on a printed circuit board, it would be pretty simple to build the LNA, but you're going to end up with 30 Kelvin noise.
So putting cooling off the LNA as best you can, or maintaining its stable temperature, is probably the best thing you could do for that right now.
That helps.
Okay.
Sure. Peltier cooling, we decided not to use it on this big array of thousands of LNAs because of icing, condensation of moisture. You have to seal the LNA so well to keep it dry that it was just too much of a reliability risk. So we're running them at ambient temperature.
Okay. All right. Any more questions for Sander?
Well, either Sander or Bob, is there any sort of central place you could look up all this stuff? A list or a reading list or a tutorial or anything of that kind?
Well, there's these articles about the 7 Kelvin LNA, and there's one that's been submitted about the 11 Kelvin LNA. There is a ERSI conference in Japan in August. And a very advanced graduate student from Caltech is going, and he will present a talk about the LNA. Kieran Shylock is his name. If anybody's going to that conference and gets the proceedings, but what else is there?
I would kind of contradict what Alex said a little bit and suggest that you should try to build your own and learn about it and learn about testing, and you'll see what works and helps and what doesn't. Now, the problem is testing, and the classical way to test, there are some noise figure meters, like HP makes them. I have one myself. And to test them properly, you need a standard, something to test against, because you got to, set up your noise figure meter at a certain noise level. Well, as amateurs, what you can do is you can go pay attention to the Microwave Update Conference and a couple of other VHF conferences that happen around the country. And when they happen near you, grab up your LNAs and go there, and they'll have the right standards and the right equipment, and they'll test them. And once you have data on one of your units, you can use it as a comparison just to get a gauge of how you're doing if you try another one. Now, the wiring technique that I think you could consider is what they call Manhattan wiring, where you suspend your stuff in the air and interconnect it properly, because the PC boards can be an issue. Now at 1420, they're not too bad. You probably still be okay there, but they're beginning to start to play a bigger role in the impedance or the characteristics of the circuit, I believe.
I'm sneaking up on 10 gigahertz.
Okay. Well, if you go to B5 VJB, Kent Britton's webpage, he's
Right.
got some, I believe he's still selling some PC boards that you can buy that are, some of those are in Rogers material, which is a good RF material. Build your own. So you could buy, 5 or 6 of them.
Would it be better to go dead bug sort of construction with?
Well, if you get the right package that you can solder to, and you're adept at soldering, if you get a really small soldering iron, and don't apply very much solder, if you start dumping solder into the junction,
Sure.
you got a problem. You could certainly do it that way, and that's part of the experimentation I'm talking about. Half of this hobby is experimenting and learning about stuff and trying it out, I think. And but there are people like Sanders that's made a lifetime career of doing these. I don't know of a particular article or anything that you could get, but I have a lot of papers myself that I've accumulated from amateur radio publications and HP journals. Some of the old HP journals are really, really good. If you go searching on the internet, you can find some of those, and you just will not get the kind of information anywhere else. It was covered.
I found looking at IEEE, well, first of all, they're horribly expensive paper by paper. And the other thing is that they always leave out just enough so that you can't duplicate what they did. And I think this is a commercial problem.
Right.
And I hate to say it, but I ain't stupid. And there's just enough information missing that unless you have been working with it hands-on for who knows what at the same lab, you're not going to be able to do what they did.
Well, they're not trying to give you a hard time. I think some cases they just think that you would know what they haven't said, or they assume maybe you do, or maybe they do have a secret they don't want to let go of. But the key is the material, that the junction of the semiconductor material that the device is made from. And the key parameter is mobility. And that depends on how the thing is compounded. And there are 3,5 in the chemistry.
Indium phosphide,
3,5 material. And it depends on the the guy has to make a melt usually of it and drag it through some graphite boats to interconnect these junctions and then cut them up. He ends up with little pieces that he has to saw up, and that's what you're getting from, and that's why they're so expensive. It's a laborious, slow, low yielding process sometimes. But the interesting thing about this particular company, they have 4 or 5 different chips for different scenarios, and I believe he's probably sorting them out. So he has a really nice test lab.
Are you talking about Duramics or where are you talking about now?
Ceramics, yeah.
Yeah. I think he got pretty good yield. And let me just comment about the transistor. I said indium phosphide, that's kind of exotic material or harder to fabricate, less
Infrared.
into it. But the transistor is a 500 gigahertz F max transistor. In other words, it has unity gain at 500 gigahertz. And if you're using it at 2 gigahertz, it has superior performance, great amount of available gain. The problem for 4 or 5 years that those transistors have been available has been stability. If it is so good, if it has gain at 500 gigahertz, at 50 gigahertz, it has a lot of gain, and it usually oscillates. And we eventually found out the oscillation wasn't the surrounding circuitry, it was in the transistor itself. The transistor has 4 gate fingers, and the signal would go forward in 2 of the fingers and back in the other 2. It would make a loop in the transistor.
Sure.
What Duramics did, and some other people have done it too, but I think it was the Swiss lab in Zurich that found this, that you could put air bridges within the transistor to stabilize it. And so those transistors that come from Duramics have these air bridges. And we haven't had trouble with this oscillation. We've had trouble with very low frequency oscillation. You can imagine at a few hundred megahertz how much gain this transistor has. And you have to have very good bypassing in the bias circuitry to keep it stable at low frequencies. But the high frequency oscillation is taken care of by these air bridges. The other comment I'd like to make about the measurement, the noise figure meters, the meters themselves, even the older HP noise analyzers, I guess they were called, they do the calculation correctly. But the key thing is the ENR of the noise source. And when you're measuring very low noise, it's not just the ENR of the noise source, it's the temperature of the off source. Essentially, you're measuring the temperature of the amplifier plus the temperature of the off source,
Sure.
which is around 300 Kelvin. So you're trying to measure 307 Kelvin, and if you make a 2% error, you're way off in noise temperature. Now, HP came out with smart noise sources maybe 10 years ago. They have a temperature sensor inside, which gets transmitted in the cable to the noise analyzer, to the newer noise analyzers. However, that temperature is with a sensor in the noise diode, and it's, as I found out just a few months ago, that sensor is back in the noise diode it's not near the input attenuator.
Uh-huh.
The off noise is determined by the temperature of the input attenuator.
Sure.
And so I was seeing errors due to the temperature of the connector on the noise source. And they weren't corrected by the noise sensor in the noise source because it was measuring a different place. So what I've done now is use noise sources. I have some smart noise sources, but I ignore the input temperature sensor. I place a accurate temperature sensor on the output connector, back at the base of the connector where it goes into the body of the noise source. And let me just mention that sensor. There is getting who makes it, very common temperature sensor with a tenth of a Kelvin accuracy, absolute. It sells for about $2. And you can buy 100 of them, and they'll measure. You can stack them together, and they'll measure identically to within a tenth of a Kelvin. I haven't done that experiment with 100 of them, but I've done it with several of them. The only problem with that sensor is it is minutely small. It is of the order of a millimeter square. And you have to handle it like a transistor chip. We made a little adapter board that we can mount the sensor on and get 4 leads onto it to power it. But that's just a tip about the noise sources. If you start comparing amplifiers, you should compare them with different noise sources too, and pay attention to this temperature of the noise source.
I'll mention one more thing. I've got right here on my desk. This is Fundamentals of RF and Microwave Noise Figure Measurement, HP Journal, application note 57-1. And I'll stick that in the chat too. And it's about a 30-page document that they explain some of these things about how you go through this process using their noise figure meter.
Yes, sure.
Which, by the way, the thing is pulsed. That's how they get a temperature reading and a
Right.
cooler reading. But I'll post that on there.
Okay.
Go seek that out, and that'll help you.
Mm-hmm.
All
Can I
right.
sneak in one more question for Sander?
Oh yeah, go Richard.
Okay, we've kind of got the cold temperature nailed down. How about the ENR of the
That
source?
gets to
Do
be
they tend to?
less important if you're measuring a 10 Kelvin amplifier. I guess the specification is plus or minus 0.15 dB of ENR.
Okay.
Keysight noise sources, and I think that's accurate enough. It's that cold temperature that gets you. The other thing that gets you, though, is the variation of impedance of the noise source between on and off. That's why you have to use a low ENR noise source, a 5 dB ENR noise source, which has an input attenuator. But that return loss of the noise source coupled with a poor S11 of the amplifier can make for a big error. So what I look for is greater than 20 dB return loss of the noise source, both at hot and cold. And the LNA better have a reflection coefficient of less than 10 dB or return loss greater than 10 dB. So those are other places for errors.
Thank you.
All right.
I got to go have dinner now. Nice
Sander.
meeting you guys from down south. I've been there a few times. I've been to parks in Perth, and a lot of great astronomy gets done in Australia. Boy, they really show up the rest of the world with things that they've done.
Must be time to come to Melbourne. Sander, it's time to come to Melbourne.
Melbourne.
Yep.
Okay. Haven't been there.
Put it in your diary.
All right. Well, I'm 86 now. Do you think I've got enough years left to make it down there? Yeah.
Down on it.
Okay. I'm going to sign off.
Thanks, Sander.
Thank you.
Paul, do you got any more of your guys?
No, I think we've done the Australian end. We're a bit light on this week, this month, but we'll have a few more next month, I think. And
That's
ideally with Andrew back with us as well.
That's fine. And now we have Richard Flagg on, obviously, and you guys have a lot of guys that are doing Radio Jove down there. And I don't know if Richard, you got any updates on Radio Jove that you can tell these guys?
I don't think of anything, Rich. I'm kind of uncomfortable right now with the complexity of the software. There seems to be a lot of messaging. A lot of folks are having trouble getting their gear set up, and a lot of recommendations on software that I frankly find a little bit intimidating. So I'm hoping that we can maybe get to a point where it's a lot easier to get the SDRs set up and running. They've got about most of the ones that we've tested seem to have at least 20 or 30 dB of dynamic range, but it's important to set the gains up and so that the galactic background is down at one end and the strong solar bursts don't exceed the other end, in terms of dynamic range. So that's kind of my take right now, Rich, on things.
So this is no longer a high school radio astronomy kit.
Well, I suspect that most high school kids are a lot more advanced than I am in the software end, so maybe it is more better for high school students than it ever was. But
I don't know. All right.
Well, the SDR Play links with SDR Uno, and I think that interface is a bit intimidating for many people.
I know it is for me.
Yeah.
And unfortunately, the software seems to change version numbers daily, and so I found it difficult to keep up with the instruction set. To tell you the truth, I know Larry Dodd has been frequently putting out recommendations for installation of the software, and I hope that's helping.
Well, a move to SDR it's a big jump for many people. That's the thing. It's not just a black box that you turn on. You've got to get all the settings right.
Absolutely. Just handling where do you put all the files and the actual settings of the gains in the equipment and integration time constants and offsets, and it takes a bit of effort to get the thing on the air and get it doing the right thing for you.
Well, there may be something we're able to do at the Astronomical Society. We've got a Radio Jove antenna set up with the original receiver, but I've got an SDR Play here, and we can have a muck around and see if we can make it work. Come up with some settings that we can contribute.
I think sure that would help, and comments on the written instructions that maybe that some of the Jove folks have been provided. I find some of them confusing, some of them very helpful, but I sort of wish we could standardize a little bit more and make the documentation a little higher quality than it is right now. Not the SDR Play folks documentation, but our own.
Jove people.
So any help you can give us would be great.
Now I'll have a look and dig out some of the documentation. I haven't got the most recent version. My version is the older one, the original receiver. But I'll have a look what's available for the new SDR Play model and see if I can make some sense of it.
Another issue that we're going through right now is in the area of calibration. And Jim Sky is looking to produce a do-it-yourself calibrator. And I think he's made fairly good progress on that. But there again, if you gotta calibrate the calibrator. And we're hoping to do that using the dBm power reading in SDR Uno, which seems to be quite accurate. I've made some tests on that, and over at least 30 dB or so of dynamic range, it's good within a dB or so. But it's a kind of a complicated process to do a do-it-yourself calibrator and then calibrate that instrument to make it useful and comparable to what other do-it-yourself guys have built. So anyway, that's where the DIY calibrator issue is at present. Over.
All right. I still think I still got my ham radio with my 20 megahertz antenna, and I was able to pick out an S thing from Jupiter. So the rest of that stuff is all too fancy for me too. So anyway,
this solar cycle has been absolutely astounding in terms of solar bursts. I think, I don't know what the longest run is, but I'll bet it's more than a month of getting a solar burst every day or more. So that's, and Jupiter is pretty close to the sun right now. So I think a lot of the guys are concentrating on solar bursts. And I've seen some really spectacular spectrograms.
well,
Take
maybe
advantage of it.
maybe we can get one of the Jupiter group, Radio Jove group, to put a quick YouTube video on how to do a solar collection. That'd be great.
Okay, I'll see if that can happen.
Yeah.
Thanks, Rich.
Well, thank you. Let's see. Alex, you got anything going on? Any more umbrella antenna designs or anything you want to talk about?
Haven't been spending much time outside. It's been miserable. One comment to Don, go look at the Sarah Google group about 15 posts back. It has how hard is it to build your own LNA, and in that there are some kits, but it shows you the process of how to build one. So it gives you an idea of the complexity of what it takes to actually do something like that. What I've been doing the past week, and I sent you an email today, Rich, and I had exchanged a few emails with Bob Stricklin, was kicking around that process of spillover effects and how it affects the equivalent noise temperature of an antenna. And I got an email from the professor at McMaster University in Canada, Natalia Nikolova, and I was using her lecture notes as the basis for that spreadsheet that I was developing, and she pretty much confirmed that what I was doing was probably okay. So I think it's valid. It doesn't. It uses a lossless system, and the the reflector is only provides a certain degree of protection from ground. In other words, it's just an X number of degrees of 10K, and the spillover is 290K. So it's not involved. The equations don't involve the effectiveness or the surface area of the dish. It is only an area that blocks the ground temperature. But it seems to be a useful way of comparing different F ratios in how they affect the effective noise temperature.
Yeah, and that what you did reminded me of how the spacecraft guys did their thermal analysis on the spacecraft structures. Very similar approach, and I don't know if that's finding software. I think MATLAB has a software package for thermal analysis of stuff like that. But they basically break it up into strips and things like that, just like you did, and figure out where the hot spots and the cool spots and the heat transfers are and all that kind of stuff. So I've just never seen that used on an antenna. They may actually use it on an antenna on a spacecraft, and you might look at that and see if they've actually done a horn or a dish on a spacecraft thermal analysis. I'm sure they have. It's just a question of whether they didn't use it for your approach.
I don't know. I did a lot of searching, and I never came up with anything that quantified anything more than just maybe 50% is from the dish and 30% is spillover. Let me show you just one. I think most of you saw this before, but let me just show you the summary slide of what the results were. Just this. Oops. So all this, can you see the
Yep.
the little slide? Okay. All it does, it says what you can do is in the spreadsheet, you can characterize the beam patterns. This is the one that I actually used, and this is a narrower beam. And what you can do for different F to D ratios, you can calculate the degree of spillover, and comparing these different antenna shapes to, or not antenna, but the reflector shapes to the characteristics of the feeds, you can calculate what the relative temperature would be. And the whole purpose of this was to confirm the fact that on larger dish systems, which can accommodate the much larger choked feed, that typical dishes, parabolic reflectors are in the 0.4 to 0.45 F to D ratio, giving a reasonable temperature. But if you're going to be using a much smaller feed with a broader beam width, you need to have a deeper dish to minimize the spillover. And so it's reasonable. And that was the whole idea.
Yeah, looks nice. Paul, what's the F to D ratio on your big dish out there?
Joe might know that. I'm not sure. Can't help on that one.
All right. Well, that might Alex's analysis might help you guys figure out what kind of a spillover effect you're having. And Alex, does that have to do with distance from the ground too? Is that?
It could, in that. Let me show you what the Excel spreadsheet looks like. You could enter those numbers in. Like I said, this is assuming a perfect lossless system. Let me show you the spreadsheet. See the spreadsheet?
Yep.
Okay, so the way it works is, if we look at this picture down here, the idea is that you're going to be getting spillover. The blue area is the the area of the feed that is protected from ground temperature and is seeing the 10K cold sky, and the depth of the dish determines how much of the feed is exposed to ground. And if you do an f.25, it's completely covered. There's no ground temperature seen by the dish. So what you can do is you can play with these numbers here. I just put in a quick transition from hot to cold, and that's what these numbers look like. And what this is the beam pattern for the the loop feed. It's 150 millimeter in diameter, 120 millimeters in diameter, and I don't know what this septum feed is. It's like 16, 18 inches in diameter or something. It's huge. But this rolls off, but this has a much sharper beam width and a much greater roll off. So it has less sensitivity to ground spillover. And so this is the calculations for the loop feed and the larger septum feed. And you can play with these numbers, and you can also, what this plot, let me just change the number here. You can change numbers here, and you can see how that, what this is for each 5-degree increment, you can see the amount of Kelvin temperature that is added to the overall total effective antenna temperature. So you can play around with this and see. I mean, it's not like you can change anything, but if you were going to plan on a particular system and had a choice of picking a deeper or shallower dish, this might give you an idea of what you would want to choose.
Okay, great. And Paul, I just saw Roger Heap came on.
Hi, Roger. You got
Yeah.
anything to chip into the
Sorry,
conversation?
no, well, I came in a bit late then. Sorry, I've been a bit sidetracked, and I just realised it was on. So no, I missed most of that, but I suppose I can come back and have a look at it when it's been recorded. They do end up on the website,
yep.
Don't they?
Yep.
Yeah.
Yep.
I was actually going to ask Alex something. I've been looking at my radio Jove system has turned up, and I was going to make your your pie dish feed point for a dish, or your feed. I actually saw it in one of your videos, but I haven't been able to find it again. I was going to make one for a 1.8 meter dish that I'm using. I don't know.
Repeat the question.
I think it was you. Was it you that made the feed for a parabolic dish? I think you called it a pie tin or something. It was basically just a pot.
That's out of an aluminum cake pan.
It's a long cake pan, yeah.
But I mean, that was for 1.4 gig.
Yes. Yeah, the device that's come with the radio Jove goes from basically 0 to several gigs, so it should be okay to do that with it. That's the so yeah, I just need to make up a feed. So I was the one that you had there looked fairly simple to make, but I haven't been able to find. You had some. I did see I think it was on a YouTube clip that had some dimensions on it that I haven't been able to find it again. So do you know where
I'll find that link and put it in the chat right now.
Okay, thank you.
Hey, Roger, we got Richard Flagg on, and I'm wondering, I haven't heard of radio Jove up the higher frequencies like that. They're mostly around 20 megahertz.
I think it's the fact that Roger's talking about the fact that the SDR play device goes up to 1.7 gigs. And there are other things to do with it.
It's in my shed. I'm pretty sure it went out to 2.
Yeah.
Went out to 2 gig, I think.
Yep.
So you're planning doing radio Jove, that you want to do a hydrogen line as well? Is that what you're saying?
Yeah, that's right, exactly.
Right. Using the
I
same.
just need to make just make a feed for my 1.8 meter dish. So the one that Alex had looked fairly simple is really what it comes down to.
Yeah. Going back to the radio, going back to Radio Jove, earlier on, Richard was talking about the issues to do with using the SDR. So it'd be interesting to get some feedback from you, Roger, as you set it up, about how easy it is to interface that SDR with the software. Have you had a go yet?
Yeah, okay. No, I haven't. I really only got my antenna together last week, and at the moment I can only do a single dipole because I had a broken insulator. It obviously got broken in transit, so I'm one insulator down, which means that I can only read enough to do the one. But I've loaded the software up. I've actually had the radio, tuned it into a local radio station, so I've got that part of it actually working. So the next thing is to get the antenna up and start using it as it's supposed to be used. But I haven't quite got there yet. Only really came together last week.
So what was
Roger,
sorry,
Roger, I put the link up there.
Yep.
Yes, I got that. Saw that. Thank you.
Yeah.
So
what's the software that comes with it, Roger? Is it SDR Uno?
Yes, it is.
Yeah.
Yes. And there was another one. I haven't actually got it in front of me at the moment. It's all down in the shed. But yeah, the one that came with the Radio Jove had basically a cascade type of display on it. I can't remember the name of it now. If you mention it, I would probably know it. But it's the one that's obviously written for Radio Jove. But as I say, I've got them all to work. I did have problems setting up the software, the Uno software. I'm just trying to remember now. It wasn't easy. I had to eventually found a link. That's right. The links didn't work properly. You click on the link to take you to the software and it just sat there and did nothing basically. But there seemed to be another link that worked. I went to, on that same Uno page, or there was a link to other, I can't remember exactly what it was, but it had a link to the same software and it worked. So one of the links on the page worked and the other link didn't. Which I found weird. I looked at the addresses, all the addresses seemed to be the same, but one of them took me to the right place and the other one didn't. So, of course, I loaded up the software with the one that did. So, anyway, eventually it all came together and they all seem to link up. They just need to get the whole thing together now to see if it goes.
Richard, this might be a good opportunity then to look at, well, as Roger sets his system up, perhaps we get some feedback from him. Feed it back to the Radio Jove people.
Yeah, I suspect that he'll start out using SDR Uno, which it requires a download of SDR Uno, but you're not supposed to run it because there's a DLL that's comes along with the SDR Uno software that's required in the Jove software. One of the many points where there's a little bit of a complexity. I think the drawing, the block diagram that Roger was talking about was a program written by Nathan Town, and that allows the user to set up the various gains and time constants and so forth in the SDR. So.
Yeah. That sounds right. It had a small diagram of the basic, an electronic flow diagram, basically, that came with it.
Exactly.
And
there's
also noticed that you had to use an earlier version as well. So that was a bit of a trick. So now every time I load it up, it tells me that there's a new version of Radio Uno available. Do I want to download it? Which I don't at the moment because I assume it'll write over the version that I need. Has the elements of the software that's required for the Radio Jove part of it.
Exactly.
So that's another thing that I'm not quite sure if I can actually, download that later version and all the sections that are needed will stay there, or whether I'll wipe them out and it'll stop it from working.
And I wish I could answer that question for you, but I can't. I know that was an earlier version of the software that reportedly worked, and you couldn't run the newer versions, and some of the confusion in the software and the Jove right now, I'm afraid.
Yeah, fair enough. And at the moment, I've just loaded. I went off and found the earlier version, and I've loaded that one up, and I'll just leave it at that until I know whether it works or not. And if it does work, and I can maybe download the new one after that if it stops working, or revert back to the old one.
Right. Well, let us know how it turns out, please.
Well, Roger, we might work together on that as you get your system going, and then we can give feedback to Richard. And we can also do some experimenting at the ASV site in Heathcote as well. Do some comparisons.
Sounds good.
Yep.
Yep, sounds good. Anyway, it's all here at the moment. I've got a Super SIDS that's been ordered as well, but I got an email a couple of days ago to say that there's been some problem with the supply of parts to build it, so it won't be available for a couple of months. So I'll get that set up when I can, basically, when it turns up.
You mentioned an insulator had gotten broken in the antenna. I think you could just replace it with a short piece of PVC pipe and a couple of holes drilled through it.
Yeah. Basically, at the moment I've got a little bit of Vero board, and I'm going to play around with that.
Sure.
There was actually one comment I will make there, I suppose, and it's not a terrible one, but in the documentation it showed a feed point which would seem to be very nicely made up for the professional version. So if you get the version of Radio Jove that NASA make and ship to you, it comes with this nice little feed point with an F connector in the middle. I think it's a little bit sad they couldn't have chucked a couple of those in too, instead of have the way that you make the feed point. Well, their suggestion is to wrap it around an insulator. I assume it'll work, but it's a bit of a rougher way to do it when there is actually available a nice, neat little unit that you could just tie the antennas onto.
Yeah,
but it's not a problem. I will get around that. But it was just a comment.
I think each of these feed point insulators with the connector on them run, I don't know, between $10 and $20. So that's why you get to wrap your own around your own insulator to keep the price down.
Yeah. Anyway, it'll work. A bit of heat shrink on it just to tidy it all up a bit. It'll work okay.
Sure.
But I do need to find another insulator or make another feed point. So at the moment, I'm working with just a bit of Vero board. I think I'll just throw an F connector on it and use that for the moment.
I think
I'll get I'll get the single one that I've got working first. At least should be able to do solar observations with it, just to prove that the whole system works.
Oh, you shouldn't have any trouble picking up the sun with one dipole.
Yeah, it's good.
Been plenty strong.
I'm glad to see it's. Yeah, I'm glad it's still there. It would be lost without it.
Yes.
All right. We just had, let's see, who came on? Nathan Butts?
Nathan, yeah.
Okay.
Rich, I'm running out of time. Might do other people can stay on.
Okay. Anybody else have anything major? We're going to close in 10 minutes.
I'm going to have to bail out now. My stomach is grumbling.
Well, thanks a lot. It's a rough life there in Hawaii, but somebody's got to live there.
I'm glad that somebody appreciates how rough it is here.
That's right. I lived there for 11 years in the Navy, so I do appreciate that, every bit of it. So,
thanks, Rich.
All right, Nathan, are you on? Did you want to say anything real quick? Nope, I guess not.
No, I'm fine, thank you. I was just late getting on, so just thought I'd join and see what everybody's up to.
All right. Well, we'll get you on we'll have the video coming out. Helen, you got anything?
Not there.
No?
Me?
Oh, there you go.
Now? Okay. The only thing I was interested in, I've been going into the various postings that you had. If you were aware, or I'm sure you are, a basic radio astronomy book that I can plow my way through and start pulling everything together, because I am overwhelmed.
Isn't there is Richard still on? Well, there's a Radio Jove book that I thought was really good. And I forget the name of it. And it was a very, walks you through the very basic, simple stuff. And I'll have to go find that book. And
Okay.
but you're right. It's just you got to build up this stuff slowly.
Helen, I'm just looking on my Kindle here. I've got a book by Stephen Arnold, Radio and Radar Astronomy Projects for
Stephen
Beginners.
Arnold, you said?
Stephen Arnold, yes, Arnold. That's very good. It covers.
I'm sorry, you're fading in and out.
It covers the whole range. It's got information about Radio Jove, hydrogen line, the whole lot. So I'd recommend that one. I'll put it in the chat.
Okay. All right. Well, thanks, Helen. We can. That's something we can start finding some good books. Charles Osborne. And sorry you can't make it the Eastern Conference, but you were measuring LNAs at one of the past conferences you were at, and I don't know if somebody else can do that this year.
Yeah, I've got the noise figure meter, but yeah, that was a good discussion today. Definitely enjoyed hearing Sandra talk about all the tricks, and Bob, you too. Yeah.
But so you're not going to make it, so I was wondering if you were going to.
No, I don't
somebody
know.
else.
I don't know who else would have one that is going to be there.
All
Send
right.
me a list of who's going to come, and I'll check around, see if there's anybody that could take it. Bruce has one. NT4RT, he'll be coming, I think.
Okay. Let's see, Joe.
No, I got nothing. Hopefully I'll have a little bit more to report next meeting so far as getting this hydrogen line thing and maybe getting some data to Ted.
Yeah, I think it's going to be a great help, and it's really fun to do. Once you start getting data, it's almost like you want to get more.
Yeah, so. But nothing, nothing.
Let's see, Ted, I don't know if you got anything else you want to say, and then I think we'll call it.
Yeah, I'm back. We have an electrical storm and we had a brownout. But I see the Radio Astronomy Projects book was posted on chat, so I'll look into that. That would be great.
Yeah, it's a good book.
Okay, Stephen Arnold.
On Kindle, it's not expensive.
Okay, yeah. Okay, I'm very grateful. Thank you for all of your help.
Okay.
Rich, you called my name, but I have nothing more to add. It's just fun to listen in to all these interesting subjects. Nathan is trying to build a telescope, and he's learning a whole bunch. I think it's great.
That's perfect.
Okay, thank you. Good night.
Night. Paul, last word.
I can try to pop up a picture here for you, Rich, if I can, if I have time.
Wait, do what?
I have a shot I can pop up here if you want to see it.
All right, we got 4 minutes.
All right, I'll make it quick. This is my global meteor camera catching meteors last night. There was a lot of meteors coming into Earth these days. Some of the things that look like blinking lights, those are airplanes, but most of these are meteors, about 35 of them. So That's a lot of fun. And I got my magnetometer in the ground and working 42 inches down, and the temperature is very stable at 25 degrees C, 42 inches down. So I'm pretty tickled about that.
In your picture over on the left, there was a diagonal one that had like little circles as opposed to dots. I was puzzled by that. Overexposure or something, making circles?
Well, the circles, there are star trails in this too. I guess you realize that.
Underneath your cursor, they
That's-
look like little boxes going up.
Yeah, little circles.
Move your
Little
cursor.
circles are just the camera artifacts of the camera, I think, and the
The artifacts, yeah.
It's not
Okay.
it's not sharply focused. This is one of these really inexpensive Chinese cameras, and they really are hard to focus. And I try to do it looking at the stars at night, but the feedback loop is real slow on the computer. So, but they're adequate for these meteors. And if multiple people sight a meteor, which happens all the time, then they can calculate the trajectory and figure out where it would hit the ground if it was large enough to make it. Almost all of these burn up in the sky, but some of them do come, and usually they're fireballs or really get bright towards the end of the cycle if they're fireballs. And I've captured a few of those. And you see other funny things happen during the night. Like last night, I had a really bright spot that showed up for just a very brief time. And I don't know what that was, but it almost looked like a supernova or something happened. And you just happen to catch it in the sky. So you can do a lot of astronomy type things with these little cameras.
That was coming right at you. And so,
Yeah, that's right.
Yeah.
Duck. You need to duck.
Bob,
Aliens.
I'm fascinated because we want to make a look up, a video camera pointing straight up for meteors as well. So given that image, so how do you get any kind of coordinates out of it? You try to figure out what the constellation is behind it or what?
Yeah, you have to go through an alignment process for the camera at the very beginning. You set your camera up, you aim it, and then you have like a 24-hour period where you've captured your stars. And then after you've done that, there's a process I could point you to that you can pass that image back to a computer system that's set up on the net, and it'll figure out what you're looking at and give you your coordinates.
Yeah, and get you matching. Okay.
And then you
That's
can
what I
characterize
thought.
your lens, and it takes the imperfections, some of them out of the lens with software. It's a really fascinating job that several people in Canada and other places have done all this work. And it's just an amazing thing. If you go to Global Meteor Networks, I believe it is, you can find details about this. The camera's about $130, $140, and then you need maybe a Raspberry Pi or something to connect it to capture data all night.
So I should Google Global Meteor Networks. There are so many of them.
Yeah.
Yeah.
Thank you. I will check it out.
What are the dotted lines?
Those are the stars that are at an angle, the ones that were at an angle. Am I still sending that picture?
You got to put it up again for us, please.
Yeah, so those dotted lines on an angle of about 45 degrees are stars moving through the sky. So what this is a montage of every time it saw a meteor during the night. And therefore the stars move through the image because it's a collection of multiple images. You can also watch a video of what the sky looked like continuously through the night. And that's also fascinating. But so where you aim your camera will depend on what these stars look like. And if you aim it at the Polaris star, for instance, you get a circle on here. I think that's what Paul showed us one time earlier, essentially, which was really a fascinating talk you did. That time I enjoyed that very much. But anyway, you could also, if you had a little better camera or you were careful about it, you could look for variable stars and characterize them as well. There are people trying to characterize light pollution in the sky, the amount of light pollution. And I've got my camera pointed east a little bit because that's like the leading edge of the Earth. And that's where you're going to see usually more meteors earlier in the morning.
All right, great. I think we're going to call it for this month. Paul, you got any last words?
I'm just interested in Bob's reference to his magnetometer and 25 degrees underground. I've just went up to Darwin for holiday and got the GAN railway down to Adelaide, stopping off at Coobapedy, which is a very hot place in Australia. And a lot of the houses there are dug down into the ground, and they are at 25 degrees all year round. Great stuff. So it's 40 degrees outside, 25 degrees in your house. No air conditioning, no cooling, no heating, no nothing. Interesting place to go. Opal mining.
I've seen that kind of a thing where people build windows in the side of the house and then they put scenes in them and lights that change during the day to make them feel like they're looking outside.
Yes, that's right. That's exactly right. Yeah, there's an underground church and there's the icons on the wall, all backlit. Looks like you're looking through a stained glass window. You're not really. You're looking through a, backlit.
Back to the Future. I'm sorry.
I was thinking about trying to put my LNA down underground and just run a feed line.
Yeah, yeah.
Feed of the dish to try to keep it stable.
I'll dig out some photographs, Rich, for next time.
Yes,
All right.
Living in the underground motel really tests your belief in whether or not you are claustrophobic.
Yes, that's right.
All right.
All right. I'm going to scoot off. So,
all right. Thanks, everybody.
All right. Thank you.
Okay.
See you next time.
See you. Thank you, everyone.
See ya.